Welcome to Severe Weather Analysis for Brisbane. I'm your host, and today is Friday, January 16th, 2026. We're looking at the atmospheric environment from this morning's radioactive sounding data and what it means for severe weather potential across the region. If you find this analysis helpful, please like and subscribe to support continued severe weather analysis. Let's start with what we are seeing this morning at 10 a.m. local time. The Skew-T diagram shows a stable environment with a moderate cap holding everything down. The red line represents the actual temperature profile, while the green line shows the moisture levels. We're looking at mixed layer CAPE of only 265 joules per kilogram, which is well below the Australian threshold of 1,000 joules per kilogram. That's the energy available for storm development. The surface is very moist with a dew point just 0.9 degrees below the temperature, which is favourable for any storms that do manage to form. But right now, that moderate cap is the dominant feature. We can see it clearly labelled on the diagram. This inversion is holding the energy down. The freezing level sits at around 4,800 metres, which is relatively high. Wind shear in the 0 to 6 kilometre layer is 18.9 metres per second, which is actually favourable, but without the energy, shear alone won't trigger anything. The most unstable parcel shows nearly 1,000 joules per kilogram of CAPE available, but it's sitting at the surface level, which means you'd need explosive heating to unlock it. The bottom line this morning: we are locked and loaded, but the cap is firmly in place. Now let's look at what happens when the sun starts working on this environment this afternoon. The enhanced Skew-T diagram shows three different parcel paths: surface-based, mixed layer, and most unstable, so we can see the full picture of how instability changes. Notice the most unstable parcel, shown in pink, reveals the hidden fuel in this sounding. When we remove the cap by forecasting a maximum temperature of 31 degrees Celsius this afternoon, the transformation is dramatic. The surface-based CAPE reaches 957 joules per kilogram, still below the Australian threshold but getting close. The mixed layer CAPE stays low because the mixed layer is drier and more stable. But here's the critical part. The blue shaded area on the left side of the diagram shows the cap, that moderate cap we saw this morning. As the surface warms, that cap weakens. The cap break temperature is forecast at 29.4 degrees Celsius, and with a high probability of 85% that we'll reach our maximum of 31 degrees, we are very likely to break through this cap this afternoon. The most unstable parcel path shows the greatest potential. If a parcel from lower levels gets lifted, it could release 957 joules per kilogram of CAPE. The wind shear remains consistent at 18.9 metres per second in the 0 to 6 kilometre layer. The lapse rate from 700 to 500 millibars is 5.7 degrees per kilometre, which supports convective development. So the afternoon environment transforms from lockdown to conditionally severe. If something manages to trigger, the energy becomes available. Today's environment over Brisbane is currently stable with a moderate cap limiting severe weather potential. While the afternoon brings some instability through solar heating, we are not expecting significant severe activity. Tomorrow tells a different story. Much stronger shear combined with greater instability creates a more favourable severe weather environment. Always consult the Bureau of Meteorology for official forecasts and warnings. This analysis is provided by Distant Curve Remote Area Telecommunications. If you found this helpful, please like and subscribe to support continued severe weather coverage for remote Australia.